Steel World, JSW, the pellet plant in charge, Mr. Umasankar. I am told that this is one of the largest great area in the world. So, and that I am so proud, Mr. Umasankar, that an Indian design company called Nikon designed that 916 meter square great area, which is the largest in the world, and it speaks volumes of the design and engineering consultancy in India. When I joined Hindustan Steel Limited, people used to think that Nikon, everything is from, copied and all. But now I am realizing that they have done some outstanding work in JSW. And I would be grateful, Mr. Umasankar, if you can share some of the unique things of Jindal Steel, JSW pellet plant and the beneficiation plant. Thank you. Over to you, Mr. Umasankar. Actually, I didn't introduce you properly. Mr. Umasankar worked in Fomento, Goa and Tata Steel. And now, since last 10 years, he is working in JSW at various levels in the pellet beneficiation plant and projects. He is actively involved in the JSW beneficiation plant, particularly the grinding, the filtration, and the pellet concentrate production. So over to you, Mr. Umasankar. Thank you very much.
Thank you, sir.
Sharing is there.
Sir, can you hear me?
Yeah, I can hear you very well. You can.
Thank you, Bhatnagar sir, and thank you for PMAI for inviting this.
There is some volume बढ़ाइए अपना. If you can speak little. इनका ये नहीं आ रहा screen sharing.
वो ऋषभ.
Hey Rishabh, can you kindly ask, give screen sharing rights to Mr. Umasankar?
We have already given him screen sharing rights.
Acha. So why is it not coming? I don't know.
Hello, can you hear me, sir?
We can hear you, but we can't see your slides. Yeah, now it has come. Good. Yeah, carry on, Mr. Umasankar.
Good afternoon, sir. Now it is a lunch time. All human furnaces are wanting.
In the virtual world, there is no lunch time. It is 24/7 working.
Just I am sharing JSW how it was faced the challenges and how we made the strategies to overcome all the challenges.
Correct.
To feed because our beneficiation.
Umasankar, slide is not coming.
Thank you very much for inviting me for this sharing our views about the pelletization plant and beneficiation, how we are making the pellet concentrate and helping the pellet making process. And this I want to just quick go through about the iron ore scenario. Yes, as a webinar, we are projecting 300 million tons by 2030.
Yes.
Now, if you see our pellet plants, so far, I think by 2012 January, almost 120 million tons pellet plants are available. But all pellet plants are not fully operated because of some of the reason with the raw material availability and other issues. That's why when we go for the 300 million tons, we required around 500 million tons of iron ore material by sinter or pellet or lump ore. See this iron ore availability in the India. More than 75% of the iron ore is located in the northern area. For JSW Steel, it is a very big challenge. We are going up to 24 million tons by 2030, getting the raw material and to fulfill our plant and the pellet plants. That is the biggest challenge to us. And as we all aware that hematite and magnetite ratio, how much it is available, and it is already explained by previous speakers. And next, you see that medium grade Medium grade means around 55 to 62 grade. That is average, it comes around 57, 56 grade. That is available is around 68% of the total reserves is available in India. That is the biggest challenge. Now we are utilizing only high grade and very few quantity of this medium grade material through beneficiation. Now, when we are targeting for 300 million tons of steel, then we have to totally depend on low grade and medium grade material to beneficiate and process pellet and center plants. What are the challenges we have with the beneficiation? Hello.
Yeah.
As we know that faster exploitation of the high grade material, because when we projecting 300, we
Mr. Umasankar, we are unable to see the slides. So can you please, from a technical team, they say if you can just close the slides and reopen. I think it will work.
You can close the slide and reopen, sir. I'm sorry for this, but this is all technical glitches.
It is from there, sir.
now,
Now it is there.
I think if I convert to slide slow, it is having some problem.
No, it is now we can see it, sir.
Okay.
It is coming.
Now it's okay?
You can make it again. Yeah, carry on, we can see now. I think all others can also see.
If you see the challenges, the faster exploitation of high grade, we don't have an high grade in the future to feed to the blast furnace and the pellet plant, direct grinding and the pelletization and other these things. And if you see the bigger steel plant sourcing of iron ore, because we don't have a captive mines, we have very few mines and our requirement is very huge. So we are depending on so many local and very small iron ore sourcing from Karnataka and other areas. And you can see the very inconsistent quality of material and the heterogeneous mineral characteristics and high manganese iron ores. It is in Chitradurga and other, even Orissa area also what we receive. High LOA, that is low grade minerals. And usage of subgrade iron ore is a challenging, and a lot of stacks is available near mines, and already some in the previous that sale is also having a huge stack. Such type of material need to be used. And utilization of this slime. If you see the slime, earlier they used to just having a washing plant, all minus 150 microns they are throwing into the tailing dams. That is a huge quantity is available for the beneficiation plants. And the Fe cutoff was reduced to the 45, what I heard is the 35. That is a big challenge to all beneficiation plants and iron ore users. And infrastructure to move this material from mine to the steel plants is the biggest challenge.
Your slides are not moving. You are on the first slide itself.
Okay.
Somehow it's we are requesting steel mint, sir, dekho. Rishabh, Mr. Umasankar's slides are not moving.
Sir, Mr. Umasankar ji, are you using any HDMI to or some external device to project your screen?
No. I'm directly connected to this laptop PC only.
There is a slight lag that we are getting as an output. So probably you might have to close it and reopen once. There's something at the device's end.
But try kariye, Mr. Umasankar.
Is it visible now?
Yeah.
It's visible, but it is not moving, he says.
Okay.
So just
Try the next slide.
Yeah.
It is visible any other slide?
The only first slide.
You go for second slide.
I don't know what is the checker.
You can go ahead with the.
You please go ahead. I'm sorry, ab kya kiya jaye. There is some technical glitch as our steel mint fellow is telling.
Okay. Just I will go through just.
What we can do is your presentation, if you can send separately, we will upload it. Right now, you go ahead with the, as per your word, you just keep speaking.
Okay. As Biswal sir already is explained about the minerals, iron ore minerals. It's having a different kind of minerals and different means a crystal structure. It's having its own hardness. Because we, as a Jindal, we receive around 22 mines material. It is having a very heterogeneous material, having a different characteristics and different hardness. That Fe is also is varying from 47 to 60 K. Actually, this is very heterogeneous. This we cannot able to feed directly to the plant. What we are actually making this these all heterogeneous material we categorized in as a high alumina and low alumina.
Yes, carry on. We can listen to you, sir.
Just okay, I will go through this.
Yeah, you just keep on speaking. We will put the slides later and this thing. Yeah.
If we can share the PPT, we can do it.
हाँ आ गया it's come.
Now it's come.
Again it vanished. I don't know what is it. It came one slide just now we saw. My suggestion is, Mr. Umasankar, you continue with your talk.
Yes, yes.
Now it has come again.
As JSW, sir, we
Okay.
are. Hello. Hello.
Yes, your slide has come. Yeah.
I will.
Iron ore mineral characteristics. Yes, correct.
It is now. It is visible.
Yes.
Okay. These are the mineral characteristics. Everybody knows that it is having a different hardness and different mineral characteristics. What we receive that material from different source is having a very wide variation in the mineral hardness and also crystal structure. And we have a different work index of all different sources. That's why what actually we are having a challenge is the sourcing that material of different kind of material and feeding to the directly into the beneficiation is a big challenge to us because we are treating almost 45,000 tons per day. That's why what we are doing is we are making some uniformity in the mineral characteristics by blending means by blending similar characteristics of raw material and we are feeding to the plant. Can you see the flow sheet, sir?
Yeah.
Yeah. Okay.
We are having a very robust beneficiation plant. We are having around 24 million tons beneficiation plant set up in Vijayanagar. And we receive the material from various sources through rail, road, and also pipe conveyor we have. And all these material we are blending properly and feeding to the plant. In the first primary section, we are having two-stage primary classifiers where we are desliming minus 150 microns, and further we are taking into the jig for the upgradation. All minus 150 microns we are desliming at minus 10 microns, and we are processing through the spiral concentrate and HGMS. This after jigging, we are whatever the product we are getting from the jig that we are converting into pellet, and this all fine material through cyclone and the finer section, that is also we are converting into pellet concentrate and sending to pellet plants. And some jig plant product, some partly we are sending to the base mix where they can able to blend and feed to the center plants. And we have a tailing beneficiation plant also, where we can able to treat minus 10 microns about 60 to 65% by having a two-stage magnetic separator to produce around 61 grade. our 61 grade product, and our final tailings is around 38 to 42. Our input grade is around 56. This is our raw material and the beneficiation plant. This is the feed and products. We feed around 56 grade and we will get around 60 grade pellet concentrate and sinter product, and final tailings will be around 38, 39. In the beneficiation plant, we are come across some challenges, because I told it is a very big steel plant. We are having around 16.2 million ton pellet plant, 4 million tons, two numbers, and 8 million tons recently we commissioned. And we have a sinter plants, 4 sinter plants. To feed all these downstream agglomerates, we need to have a consistent product to feed to all these units. That's why we were facing a lot of problem. Our raw material which we receive from various sources, pipe conveyor, rake and road, it is having all very heterogeneous material. We could not able to get this product very consistent. That's why what we did as a challenge, we took this all three materials and we made some categories. Because in the source, if you see, we are having a 60 grade Fe input and also 47 grade Fe, and also very high alumina up to 9%, even silica is up to 16%. There are so many sources. In one blend, we are feeding almost 12 to 13 sources. That's why every source is having a different characteristics and different mineralogical this thing. Because it was very initially it was very tough for us to maintain the consistent product quality to our downstream pellet and sinter plants. That's why what we made, we made a mapping of the minerals of different similar characteristics, where we can able to match the product requirement based on the blending and give it to downstream. And we have a twin boom stacker where we can receive all this material from various sources, like through pipe conveyor and truck and rail. And we are uniformly making a stacking. Then we are reclaiming through barrel reclaimer and feeding to the beneficiation plant, where we can able to maintain the consistency in the input raw material, where that equipment also can respond well and give the product quality consistently. That is the aim. That's why we thought that the blending is a process where we can able to minimize the. Then we found the results before blending and after blending, that of standard deviation come down, and consistency in the product also it was maintained for the requirement of the pellet and sinter plants. And if you see. If you see the size and other for the pellet plants also is a very minus, means blame number and other this thing is maintaining. With this heterogeneous material is having a different hardness of the material, grinding and grinding is also a big challenge, because every day it is a challenge, and every day the material is getting a change with the hardness. That's why we have a very blending system where we can able to get the good consistent results for supply to the pellet makers. And recently we commissioned that 8 million tons pellet plant in Vijayanagar and also Dolvi. If we see the Dolvi and the Vijayanagar example, in the Vijayanagar we have a processed material we are grinding. There we have a closed loop grinding with cyclone. Where we have in Dolvi, we are receiving raw material directly from the mines, minus 10 mm material, where it contains this minus 45 microns is around 30-35%, minus 150 microns. That's why what we did, we have gone through the pre-screening, where we can able to remove all minus 1 mm material and taking it to the cyclone, and only the coarse material will go to the mill, where we can able to maintain the blend number for the pellet makers. And even in Vijayanagara also, initially we were facing a lot of problem with the mill with the closed loop grinding, where we could not able to feed with the lot of issues with the mill. What we did is the cyclone which they supplied along with the mill was not able to take the load, and also it is not suitable for that particular mission. That's why we, out of the way, we modified the cyclone internals, where it is not available with even the designers, and where we could able to take up these mills up to 300 and 325 TPH, where we can able to reduce the load. Earlier it was around 400 recirculating load, that we cut down to around 200. Then that blade number also, it was giving around 3,500, that we brought down to 2,500, 2,400. These are some strategies we developed internally, and modified the circuit, and we can able to feed all pellet plants in our Vijayanagar. Some of the cyclone where we used was out of the way. We modified with by taking the help of the R&D, and we have done some work on that. And way forward, that exploring the usage of lean iron ore deposits economically is a big challenge for the all beneficiation engineers and beneficiation plants, and utilization of the huge tailings. We already having a tailing beneficiation of last 8 years. We are using a pond slime recovery unit in our Vijayanagara, where we can able to recover around 58 to 60 grade iron ore concentrate from the pond, where the pond tailings is around 40-45 grade. And tailing management system, if you go higher beneficiation plants with lean grade ore, tailing disposal is a biggest challenge. This was given some light on Mr. Tailing filtration and other. It was technology was available. That was given by Mr. Previous speaker. The tailing disposal also, and more focus on developing the various beneficiation equipment for the -100 mesh is required for this scenario, and also explore the new technology for the dry beneficiation. Now it is very difficult. Now is the way is only that reduction, roasting and beneficiation is the only way. As Mr. Biswal is already coming up with some techniques, and JSW also is already commissioned a pilot scale to do this. We used BHQ material to convert into magnetite, and again separate up to 62 Fe recovered, and also around 70-75% of the Fe we recovered from this. And all beneficiation plants is required high level automation, where we can able to visualize the process and also efficiency of the equipment for the higher this thing. So these are, sir, I could not able to show my slides properly, so I could not. This is my end of the presentation. Otherwise, I would have some slides where we can able to show some cases where we can able to do better for the supplying the good quality of material to the downstream sinter and pellet plants.
Thank you. Yeah. No, we are sorry for this. Somehow, there is some technical effect. I think because of COVID, we are also learning this technology of Zoom. So I am just saying, but your presentation was fantastic, and we have heard so much about JSW beneficiation plant, and I am very sure your full presentation we will put on our website. Of course, if you agree. And so that people can benefit. Mr. Umasankar, I very strongly feel as a plus 70-year-old person that we should, knowledge is for sharing. And this is a knowledge sharing exercise.